Welcome to the video lecture by Dr. Biju Vasudevan for the chapter for this course Mathematics for Management 1, which is the course code for this course is math113, and this video is for week 11, chapter 6.7, Leontief's input output analysis. Yes, as a brief introduction about the Leontief method is. This method, Leontief input-output analysis, was developed by Vasily W. Leontief, and he has won Nobel Prize in economic sciences for the development of this model in 1973. Okay, let's go deeply into this one and check what is all this about. Some previous videos given by me on your blackboard gives an idea about finding the inverses of a matrix by using the Gauss-Jordan reduction method. And we would like to use the same method here to find the inverse of the matrix, and the inverse of the matrix will be used further to find the solution, which is a production matrix of this model. Okay, let's see what is this one. Closed model. Assume that a simple economy consists of three sectors. Energy, manufacturing, and services. See, yes, a closed model has been shown here. Here, energy sector takes input from manufacturing and of course from services. Energy takes its own production, some part of its own production as its own input. So this works for every sector here. This is a closed model, and we're gonna see a kind of table here in this model. If we get a table like this, energy, manufacturing, and services. Here again, energy, manufacturing, and services. If you get a table like this, what does it mean? That's it here. 300, and from others 500, 400, 80, 160, 160. Okay. Services, it is 240, 480, 240, and 240. That is a final demand. This column you will get some other data as 260, 140, 500. Leave this place. See, the body matrix of this table is this one that involves three sectors: energy, manufacturing, and services. Isn't it? Here again, energy, manufacturing, and services. Here each row represents the output of every sector. So that is energy. This row, the first row, gives an idea of what is the output of energy, total output. You can add this row. This first row, the first row total will be, when you add this one, this entire row, all the four elements in the row, 500, 900, 1000, isn't it? So the first row or the first column, both will be same. So first column total is 1000. What does it mean? The total output of energy sector is 1000 has been shared as given here. That is the energy sector takes 100 units from its own production, and manufacturing sector takes 400 units from energy sector, and services sector takes 240 units from energy sector. So, and the rest will be related to for final market, final demand. So this is how the output of energy is shared among the other sectors, including the final demand, isn't it? So here every row represents the output of the sector, and every column represents the input taken by every sector. So in the first column says that energy sector, for producing 1000 units here in the row, it needs to consume 100 units from its own products 100 units from manufacturing sector and 300 units from service sector. Rest of the 500 from the other market, the outside market, isn't it? So these three, when we consider only these three sector and the exchanges between them, that means energy, how much energy sector gives to other two sectors and how much they take from other sector, it will be a closed model, isn't it? This is our internal demand table. Actually, by using this table, we will find, we have noticed here is total input is equal to total output in every case for every sector. This is the basic assumption of this model. We work out these problems on this basic assumption that total input is equal to total output. Okay. Now let's find the ratio of each sector's input by dividing every column element by its own column total. That's what we are going to do in the next tables. Okay, I'm giving an idea about what is going on here. So first element is 100 and its total column total is 1000. Second element is again 100 and its column total is 1000. Third element is the first column, third element is 300, its column total is 1000. This is for energies sector, this is for manufacturing sector, this is for service sector, and final for others it is 500 over 1000. This is the column for energy. Next, the column for manufacturing, we get the same. 400 is the element and divided by the column total, it is 800. Now 80 over 800 and 160 over 800 and 160 over 800, isn't it? So here finally service sector gives 240 over the third column total or third row total will be 1200. You can check the total, and then 480 over 1200, 240 over 1200 from others. How much they take? Service sector takes 500 out of 1200. So this is the ratio that we form, isn't it? Now final demand will be as it is, no change. So if we consider this one as the ratio, this matrix among the three sectors is our coefficient matrix. This ratio matrix A will be 1 over 10, 1 over 2, 1 over 5, 1 over 10, 1 over 10, second row, 2 over 5, third row, 3 over 10, 1 over 5, and 1 over 5. So this matrix is called a coefficient matrix. So from this one, what we understand is the first column gives an idea that to produce 1 unit of output, the energy sector, this is the first column. You remember the first column is for energy sector. To produce 1 unit of the output, the energy sector takes 1/10 of the unit from its own sector and 1/10 of the units from manufacturing sector. This is energy, manufacturing, third service, and 3/10 of the unit from services sector. So this ratio gives how much percentage it consumes from other sectors to produce one output. Obviously, when you multiply here the total output For the first row it is 1800. For second row and third row it is 1200. When you multiply first with this one, you will end up with this matrix. The first matrix. See the video, you can see the first given matrix for the first three sectors, not for others and final demand. So this will give you the internal demand a closed demand, right? So we call it C, which is A times X. We know A is a coefficient matrix, AX is this output matrix, total production matrix. And so remember that C is A times X, and we are going to use this one to derive the formula. The formula is here. So what is it? X is total output, which is equal to internal demand C and external demand D. External demand D is the column given the last in the table that we are seeing. The last column, there was a column external demand, isn't it? That is our external D. And C is known as C has been found as A times X. So we now replace this one. X is equal to AX plus D. Remember here every element is a matrix. So how to do matrix subtraction, matrix multiplication, factorization, everything should be carefully done here. So this is 1x is I times X. We can write I is identity matrix of the same size of the A matrix, and this one I minus subtract AX in the left side, it is equal to D. Now X is common factor, X is out, so this is I minus A times X is equal to D, because when you take the factor X outside, it will be 1 here. It's not 1 in matrix, it's the identity matrix. So identity matrix. So our aim is to find production output matrix X, which is D, the inverse of this one, I minus A whole inverse times D. So this is the formula given here. This is the formula that we are going to use in this chapter to find the total output matrix. So the output matrix for every sector, this X will give you total output for every sector if there is any change in D. Isn't it? If there is any change in D, we can find the new output by using this relation. And some assumptions of the Leontief input-output models have been given here. Each industry appears in a row and in a column. The row shows the output of an industry and the column shows the input of the industry, and a major assumption is total input is equal to total output. The input-output analysis allows us to estimate the total production of the industry. We call it X, total production of the industry. If there is a change in the demand is D matrix, isn't it? As long as the basic structure of the economy remains same, basic structure will remain same. So the inner demand, external and internal demands. So internal demand slightly varies, but the structure will remain same. Total output should be equal to total input. So this is the formula that we are going to use to find the output matrix X. Let's start with the first example. Given an input-output analysis, see in this problem, you read it carefully. There are two sectors given, steel and coal. So we will solve only this problem, and the rest of the problem will be for your practice. See, every sector appears in the column and in a row, isn't it? So in the column, this is for the steel, the input of steel sector, and this row represents the output of steel sector, isn't it? Total of this row is 500 plus 500 plus 200. This is 1200. For the coal sector, what is the total of the row? Total output 400, 600 and plus 1500. So column total will be same, 1200 for steel, 1500 for coal, isn't it? and this space is empty. Now what we are going to do here, we remember the formula for finding production is I minus A whole inverse D, and remember that D is the demand matrix will be given in the problem. Find the demand. If final demand is given in the question, the final demand changes to 600 for steel and 600 for steel and 805 for coal. So we know that 8D is 600 and 805. This is a matrix, a column matrix now, 2 rows and 1 column, isn't it? Okay, fine. Now let's find what is A matrix from this table. See, as there are only 2 industries involved, isn't it, in the closed model. So we will find the ratio matrix, which is a coefficient matrix. So we are going to divide every entry in the matrix for steel and coal and other sectors, isn't it, by its column total. So what you are going to get in new matrices. First, for steel, this column 200 divided by 1200, and coal 400 divided by 1200, and then other sectors 600 divided by 1. See, as there is a question, find the total value of other production cost, we need to find the ratio for other sector as well. Otherwise we need only the 2 by 2 matrix of steel and coal. If the second part is not available in this question, so we don't need to find the ratio for other sectors. But here, find the total value of other production costs. Actually, this table is a production cost table. Okay, fine. Let's do it for coal as well. Coal 500 over the column total is 1500. So 500 divided by 1500. 200 divided by 1500. As there is a question about other cost, we will find the ratio for other cost as well. 800 divided by 1500. But remember, our coefficient matrix deals for only internal demand. So we take A only for the first 2 rows and 2 columns. And so that will be our A matrix given here. And when you simplify this one, you get this matrix 1 over 6. A matrix is 1 over 6, 1 over 3, 1 over 3, 2 over 15. This is A matrix. See, this formula involves only 2 terms. I minus A whole inverse and D. What is I minus A whole inverse? We should subtract A from I matrix. I is our choice. We take I, which is of the same size of A matrix. So the I is identity matrix. So 1 0 0 1. This is our I matrix. Now we know how to add or subtract 2 matrices. We use this concept to find I minus A. We will find I minus A and then find its inverse by using reduction method. That's the next step. We will see the I minus A calculated in this step. Here I minus A. I is 1 0 0 1 and minus A vector 1 over 6, 1 over 3. 1 over 3, 2 over 15. So term by term subtraction, 1 minus 1 over 6. 1 minus 1 over 6 is 5 over 6. 0 minus 1 over 3. Minus 1 over 3. 0 minus 1 over 3 again, minus 1 over 3. And 2 over 15. 1 minus 2 over 15. 1 minus 2 over 15. What is it? 15 minus 2. 13 over 15. This matrix is called I minus A matrix, and we have to find the inverse of this matrix by using inverse of by any method. We have not specified any particular method in this model, so you can use any method to find inverse. The method that we have discussed in this particular syllabus is reduction method. So this is called reduction method. The reduction method has been given to you already. So you are going to use the reduction method to find the inverse of this matrix. If you know the inverse of this matrix, I minus A whole inverse, and we have our D matrix, we multiply in the right side, so we get the final output matrix X. This is our purpose of this problem, right? So finding I minus A whole inverse can be done as follows. So the first step, we have this I minus A here, isn't it? So what is the idea of finding inverse? That we have seen in the previous chapter, inverses. You have a matrix A, then take the same size identity matrix, write the augmented matrix. Now this is the full matrix A and I, isn't it? Reduce the A. We are going to reduce the A to a reduced form. You have to reduce the matrix, and then I will be a different matrix. By using the same operations, I will change it to a different matrix B. If R is equal to I, if R is looking like an identity matrix, then B is our A inverse, isn't it? This is the logic. Instead of A, we are using I minus A. I minus A. This is our I minus A matrix, isn't it? I minus A matrix. Now we are going to find the inverse of this one. Okay, the inverse can be found here. This matrix I minus A, I am taking here 5 over 6, negative 1 over 3, negative 1 over 3, 13 over 15, along with the identity matrix of the same size 1, 0, 0, 1. This is the entire matrix now. A matrix with the 2 rows and 4 columns, isn't it? Now purpose is to reduce this matrix, and then the right side matrix will be a new non-identity matrix, isn't it? That's it. So let's try. By the logic, what is the concept of reduced matrix? The leading element should be 1, and other column in the element, the other column elements in this column should be 0. Of course, in the second row again we need to get a leading element as 1 and the other column elements 0 until possible, and there is no 0 row available, there is no problem. If there is a 0 row, it should be in the bottom. Okay, so first operation is given here. Multiply the row 1 by its by the same number, that is the invert the coefficient. 5 over 6 can be written as 6 over 5. That is our row 1. Now what is it? Okay, you can follow these steps given here. What is it? 5 over 6 divided by, multiplied by 6 over 5 will be 1 minus 6 over 15, 6 over 5, 0. When you simplify this one, it will be 2 over 5, isn't it? Second row, no change at all. Write down as it is, negative 1 over 3, 13 over 15, 0, 1. This is the first step, isn't it? When you simplify this step, this will be this matrix. And the next step, from this matrix we have to move ahead. So first element is a leading element, and now this column element should be 0. So how to write the formula? Formula is, we are looking for row 2, right? Start from row 2, add, so if there is negative, so add 1 by 3 times R1, isn't it? So no change in the first row. 1 negative 2 over 5, negative 2 over 5, 6 over 5, 0 in the first row. Second row changes, isn't it? Row 0 here, so 0 should be there in the first element. That is our purpose. The second element, what happens here? R2 is 13 over 15 plus 1 over 3 times R1 minus 2 over 5. So simplify this one, it will be 13 minus 2 is 11 over 15. 11 over 15. So the same for this element. What you do here, row 2 is 0 plus 1 over 3 times R1. 1 over 3 times R1, it will be 2 by 2 by 5. So 0 plus 1 over 3 times 6 over 5. This will be 2 over 5. And root 2 here in the third term, root 2 is 1 plus 1 over 3 times 0. So it will be 1 here. So that is this matrix. And finally, one more step, we have to convert this element into 1 and then this element to 0. Then we got the reduced matrix. What is it? Let's take this. Now let's take this matrix and then proceed. So here this element should be 1. So multiply by 15 by 1, isn't it? So 15 R2 is R2 multiplied by 15 over 11. So what do you get? Yes, there is no change. The first row 1, negative 2 over 5, 6 over 5, 0. Second row, this will be 0 when you multiply any number with 0. So 11 over 15 multiplied by 15 over 11, it will be 1. Here 2 over 5 multiplied by 15 over 11, this will be 3 times 6 over 11. And then 1 multiplied by 15 by 11, so it is 15 over 11. So now we got this matrix, isn't it? And the only one step remaining is convert this element into 0. So write the formula for this. R1 is start from R1. So this negative sign over here is positive. 2 over 5 times R2. 2 over 5 times R2. That's what given is here. 2 over 5 times R2 is given here, isn't it? When you do this one, here 1, 0. There's no change in the second row. 6, 11, 15, 11. Change occurs in the first row. This will be 0 and these two terms should be calculated in the same way. You get it as 78 over 55, 78 over 55. You can check by using the same. Taking again 6 over 11 here. So this matrix, this is now identity matrix. If this is identity matrix, then this is the inverse matrix. Otherwise, if this is not an identity matrix, you say that the matrix does not have inverse. Okay. So here it will have inverse in for Leontief matrix. So this is our inverse matrix shown here in this problem. So this is the inverse matrix I minus A whole inverse. Now the final step is this one. X is the matrix, inverse matrix has been written here. D matrix from the first page, 600 divided by 600 and 805. So demand matrix given in the problem. Go back to the question. You'll find 600 and 805 as a new demand. So when the demand matrix is known, multiply it with the I minus A whole inverse. So when you multiply two matrices, you will get this output. So approximately you can take a round of the nearest distance. So X has two different values as a output matrix. Total output for the steel sector will be now 1290. It was initially 1200. And for the other sector, steel and what was the second one? Coal. For the second sector, coal, the total output initially it was 1500. Now the latest output was 1425. So that is X for steel. This is X for coal. The first part of the question is done. Now let's take these numbers with the in the beginning. Go back. In the beginning, there was a question. Find the total value of the other production cost. So other cost. So this is other cost. Ratio. This ratio. So others come here. See here. Other cost ratio for steel. Other cost for steel is 1 over 2. 600 over 1200. Other cost ratio for coal is 800 divided by 1500. So we have two different ratios, 1 over 2, 8 over 15. So take these two values and come here with the final output. XA 1290 multiply with its ratio, you will get 645. This is the other production cost for steel. and other this xb 1425 xb multiplied by its ratio 8/15, you will get 1425. This is for cool. When you find the total, it will be 1405. This is the total production cost for total production cost of other sector, isn't it? That's the end. If there is no question about total other cost, you finish here. And in this problem you can find inverse of the matrix. See, the rest of the problem has been given to you. Inverse of the matrix I minus a whole inverse can be found by many methods. uh, you can use even direct solution, that is I minus a times x is equal to d. You can directly solve this one by the way, by using the method of solving a system of equations and then find the value of x possible. There are many methods to find inverse or direct time solutions, but I have chosen here to give you the inverse method by reduction. Thank you very much. You can use these videos to solve the assignment problems and the coming online take home quizzes. Thank you very much. You can send your queries, doubts through WhatsApp, through this comments on these videos or through Blackboard. I appreciate your questions. Thank you very much, gentlemen.